guys, I'm Mike Bizarre. Today we're talking about AI sticker shock. We're talking also about the implications of data gravity. And finally, an AWS miscue. You're watching Techstrong Gang. We'll be back in a minute. All right, folks, and we're back, and our guests for today are David Nicholson, who joins us from the Futurum Group and also a member of the Wharton Business School there, and he's out in Northern California. David, welcome to the show.
Happy to be here.
All right. Also joining us from Denver, as always, our own Mitch Ashley, who works for both Futurum and Techstrong Group as our CTO. Mitch, how you doing?
Hey, everybody. Good to be talking with you, Mike and David and everybody.
All right. And finally, we have Amanda Rosani, who's still down in Texas. How are you, Amanda?
Doing well. Thank you.
All right. Let's jump into this because a lot of folks are now starting to get down the path far enough for Gen AI that they're really starting to figure out the cost structures here. And when you rely on a SaaS application or a SaaS platform of some type, you run into this thing called tokens that is the pricing mechanism, and you get charged on the input and the output. And a lot of folks are starting to say, hey, this adds up pretty quickly. In fact, we now see IBM is offering people an option for an inference engine that they call lightweight that you can deploy on your own cloud or in your own data center. The idea being you don't have to worry about the token-based pricing because you'll have more control over your infrastructure. David, are you starting to hear from folks about the cost of AI? Is this starting to resonate where people are going, hey, maybe we can't afford this?
Absolutely. Yeah, it's a concern, and I think sticker shock is an interesting way to talk about it because this is almost like unanticipated to the nth degree because people have no idea how these things are going to be priced. One development I've seen in the market, however, is taking a page out of the whole idea of multi-cloud and arbitration between clouds for cost and performance and things like that. There are companies out there that are positioning themselves already ahead of the game as an abstraction layer between the end user customer and those LLM models, as an example, but those AI capabilities, so that you can then subjugate all of these tools that are being developed now, and you can pick based on cost, based on fit for function. That's the promise. It's the universal remote control that subjugates all of these other things. We'll see how that works. But just the fact that that exists is an indication that, people are trying to get their arms around cost containment.
Mm-hmm. Mitch, we've talked in the past about the revenue flow for a lot of companies that were supposed to be making a lot of money in this space and the disappointments in Wall Street. Do you think that has a lot to do with this whole issue of the cost structure and people are kind of sitting back on, I can't really launch 20 of these projects. Maybe I got to pick 2 or 3 and hope for the best.
It's the AI exuberance is definitely hit us all, right? And some more than others. Some companies laid off people thinking, I won't need those people anymore. And now they're having to lay off regrets. We're at the brute force stage. When you think of the large LLMs, the ChatGPTs of the world, those are trained on massively different topics, everything from code to what's, in written documents, et cetera. And they take many, many resources to be able to process that kind of data. Tokens essentially are whatever you're feeding into an LLM gets tokenized, and then that's what's connected to say, what are the relationships between all this stuff? And let me pull it back together. So it takes literally thousands, if not tens of thousands of tokens for a response, for some of the responses that we ask from a model. David's point is a good one because even some of the technology vendors, I know Salesforce does this, some others, where they put a broker in front of multiple models, LLM models, and take parts of whatever the request is and hand it off to the appropriate model that can answer that question or provide that information. So my point about the brute force stage is, if we stayed where we are today and ran those large models for everything, we will never afford it. It's just a sledgehammer when we need a pick for a specific task or specific need, and that's what a lot of let's go with small language models. But I think we also don't want to ignore machine learning. I was just at Black Hat last week, and there's definitely a turn to going back and looking at how we can use machine learning to mine the data caches that we've been gathering in the security world for SecOps and many other purposes. A lot of companies are turning back to that problem and trying to use AI to do some fruitful things, which isn't nearly as compute intensive as Gen AI.
So I was going to mention, we've posted so many articles on this topic, urging business leaders to take the proper amount of time for planning and research and speaking with various vendors, determining what do they need, a large language model, a small model, a boutique model, and not just going with the first vendor, really doing their research and understanding the problem they're trying to solve with each different solution.
To that end, we see all these reports, and David, I'll throw this your way, about all these data centers that people are building out there, and there's this whole level of investment in this space. And yet, to Mitch's point, if we're going to run smaller language models, or what some people call t-shirt sizes now, small, medium, and large, are we over investing in the infrastructure on the assumption that everything's going to be these huge, large language models that may not manifest themselves on the inference side?
Yeah, that's a great question. I would. Amanda was mentioning something that kind of brought a visual to mind, along with what Mitch was saying. When you think about generative AI and the resources necessary to do something, not everything you want to do requires that kind of work. Look at it this way. What do I need? I want a picture of a cat. Well, I can type the word cat in and get 1 million pictures of cats, and one of them might be perfectly fine. Whatever the resources are involved in that retrieval, just doing a Google search, versus I want you to create a photorealistic image of a cat. Wow, look at it. It's almost as good as a picture of a cat. Well, how much did that cost? Well, that cost me $3. Well, what was the old way? How much did the old way cost? Oh, that was nothing. Essentially nothing. So small that we can't measure it. So I think what we're going to realize is that, frankly, there isn't as much unique stuff in the universe as we like to think. Not everything needs to be bespoke and generated out of nothing every time, at least based on resource constraints today. And frankly, I go back to this over and over again. This is all going to be about the cost in terms of energy to drive these things. There's a dollar cost associated with these things, but really, the dollars are going towards the cost of energy. And at 6:30 a.m. West Coast time, I checked just because I wanted to see. I live in California. We have something called the California Independent Systems Operator. They're the broker for everything electricity in the West. And I checked to see 20% of the energy going into the grid was considered renewable energy at 6:30 in the morning. Why? Because solar is not up and running quite yet, because the sun is not high enough in the sky. What's my point? We're in California. We charge 63 cents per kilowatt hour for electricity, 10 times as much as some other states. Yet 80% of our power right now, which would be going into a data center, is non-renewable. So there's a huge misalignment of sort of energy policy goals and the idea that we're going to have power for Gen AI. So might seem like a little bit of a drift, but I see all of this. Every time I hear data center, I think electricity, where's it going to come from?
I'm going to have to choose between charging my Tesla or running the Gen AI program, is what you're saying.
Cover your roof in panels. That's what I'm
doing. There's a whole nother part to it. You bring out some good things about energy. We tend to apply things on the Intel chip model, how long this current platform that Intel's been leveraging for CPUs and its life cycle. NVIDIA comes out of the gaming world where chipsets evolve every 6 months, and they're coming out with new platforms. I mean, they have DGX, HEX, the Blackwell platform. So I think one of the overinvestment risks is in 2 years, what you've invested in is seriously out of date, at least for the kind of state of the art. And also, it's very expensive to buy the kind of latest, highest priced performance chipset. So that's a delicate balance. How much you're going to spend on the best technology or the current technology, and how long? What's the life of that? Which drives up the cost. That's why some of these costs are so much, because the lifetime value of those chips are shorter, and they need to replace with the next generations, because that's what people want, right? They don't think they want to run on the old stuff until they get the bill.
Mm-hmm. Mitch, to that point, there'll be an article on Techstrong AI about this, with talking to IBM about this very issue. And they were pointing out that what they're seeing now is that the responsibility for the inference engine is moving over to centralized IT and DevOps to kind of help reduce those costs, because they have a better sense of what models actually need a GPU versus some other processor class. And that's one way people are reining in their costs.
Mm-hmm. Inferencing versus training and using kind of other parts of the GPU are much sort of the use of it versus the analysis and training of it. And you bring up a good point, which is IT organizations are used to tuning and getting the most out of their resources and lifetime value of their investments. And they don't even have to be on GPUs. It could be on CPUs. That's part of what people are looking at is this really a GPU problem, or can I get the same kind of performance on current generation CPU technology? So that, we're at such a learning stage about how to both apply AI, especially generative AI, and also what are the non-brute force ways, smaller models running on our phone, so things like that, running at the edge. So there's a lot of learning to go and a lot of experimentation to go. And to Amanda's point, part of talking to multiple vendors is learning from them, right? What do they all think the strategy is that you should be employing? Of course, they're going to have their version of it that is their products, but you want to learn from them, because they're spending a lot of money learning the market themselves.
David, there was a time when the data science people said that they were just too cool for school for those IT people, and they wouldn't need them, and they would just kind of take care of all this themselves. And lo and behold, it starts to seem like they're knocking on the door of the CIO with hat in hand. Is there some irony in all this?
A bit of irony, but obviously you're referring only to the data science people who were able to reinvent themselves as AI people, because in a lot of large organizations, the AI sort of leapfrogged over data science, and the folks who were rewarded with the coveted AI positions didn't have any data science background. So there's a bit of a dilemma there. Mitch mentioned the ever-present difference between inferencing and training, and we talk about the latest, greatest, most expensive, most resource-intensive AI hardware, and it's largely thrown at training because of this whole idea of time to market. How quickly you can train a very, very large model is critically important. Someone quoted to me recently that 80% of AI spending was essentially directed towards training now, 20% inference at the edge, and that's expected to flip relatively quickly over time. What does that mean exactly? What does that look like? And akin to Mitch's point about these deployment cycles, where we're used to call it an 18 to 36 month refresh cycle. I know some big OEMs are still selling N-2 generation servers as their main product they're selling, because people are saying, hey, I don't need the latest and greatest. But when it comes to GPUs, people are gravitating. So what's NVIDIA going to do? Are they going to push? I think my prediction is they're going to push sort of this cascading redeployment model where, yes, you must buy the latest and greatest for that time to market value of really, really quick training. And then you use the stuff that is 18 months old, 36 months old to do all of your other stuff. That's got to be the only strategy they can employ, because they can't tell people to refresh their tech every 9 months. Mm-hmm. That's not why.
Yeah, and to your point, I think NVIDIA knew this when they tried to buy ARM, right? They were thinking about this whole process and the relationship between these things, and there would be these lighter weight processors. So do you think as we kind of look at the rest of the processor lineup up there, I mean, Intel is getting beat up, but AMD's out there, and are all these companies going to make a comeback because people are going to figure out this inference engine issue and they're going to go, I don't need GPUs everywhere?
I think there's a huge opportunity, and that opportunity is the margins, the profit that NVIDIA is sucking out of every room they walk into. So there is an opportunity for incumbents like AMD, the Broadcoms, Intels of the world, if they execute well, to go after that margin in the AI space. AMD seems better positioned today than Intel does, but Intel's got Gaudi 3 coming out, and I know that they're doing a bunch of work to demonstrate that Gaudi 3 is a great substitute. If you need GPUs, they're going to make the case that, hey, you can save money doing it the Gaudi 3 open way, as opposed to the walled garden approach from NVIDIA. So yeah, the gold rush is on. The pick and shovel and pan vendors. I'm in the hills of Northern California where gold was discovered. All of those folks are getting ready to sell their wares. It's just the beginning.
And the other thing I'm starting to see, and it's just like little startup companies or spin-offs of other larger companies, is people are putting together like memory platforms to optimize GPU access. And it seems like there's going to be a whole school of accelerators and things that are used to maximize the utilization rates of GPUs. So is that another way to get after this? Mitch, I'll throw that at you.
Yeah. Absolutely. Yeah. I mean, we talk a lot about accelerators, which are kind of companion or sidecars to CPUs and GPUs as ways of helping, knowing when to apply, AI chipsets to certain problems. There's a whole nother part of this conversation we're not having, though, Mike. And we talk about training. I know around machine learning and Gen AI are different in terms of how you train the models. There's a lot of work right now that goes into machine learning applications. And interesting, I've been doing some work with a couple of companies, and it has its own life cycle, kind of like software development has it, where you're coupling a data engineer, an AI engineer, and a domain expert. And you create, they call them features or feature sets, which is basically when you've conditioned the data, you've built the algorithms, you've refined it enough that you're getting the kind of results that you want out of your machine learning algorithms. And you go through that cycle many times to get enough together to say, this is what we're going to release into production. But it's very inefficient. So there's some technologies coming on the market to kind of help the development process of that. To what David was talking about accelerating that, I suspect we'll see the same thing coming out for Gen AI to make that much more efficient for tokenizing and putting the probabilistic information to LLMs and medium and small, medium, large. I think it's more French fries than T-shirts, right? Would you like to large size that order, Mike?
My question is, as all these companies are scrambling to get this latest and greatest technology and the best chips and everything, do we have the resources to provide them? Are there enough companies to provide this technology to all these companies? Because we've seen the bottlenecks in the supply chain. So how are these technological orders going to be fulfilled?
David, want to take a crack at that one?
Yeah. So that's the big question when people are looking at companies by their stock symbols, which I try to stay away from because I'm no Nostradamus. That's one thing that's asked. What about supply chain issues? There are companies that have their orders filled for the next 24 months, where they're at capacity. It's all they can ship, and so that's one end of the spectrum when it comes to headwinds and friction. The other, though, and now this is me being, the world outside of my ears is very different than the world between my ears. I have to remind myself that every day. So inside my head, I got to tell you, this starts feeling like the savings and loan crisis in some ways. I don't want to say AI hype is just hype, or that hype is involved, because I'd be excommunicated from the tech community at this point. But look at it this way. Back during the savings and loan crisis, what did we have? We had everyone with an incentive to do one thing. People writing loans got paid to write loans. People doing appraisals got paid to make sure the appraisal was high enough so the loan got written. The people bundling the loans wanted to make sure the loans were written. And everybody in government was happy to tout the latest statistics on home ownership. There was not a single adult in the room saying, wait a minute, are we being irresponsible here by any stretch of the imagination? Right now, here's the issue we face, especially in the US. 40% monetary inflation over the course of about 5 years. The savior for our economy globally and in North America is AI. It's technology. That's what's being sold. It's the idea that the only thing that can deliver us from this is this pushing out of the production possibilities curve, to use the econ way of looking at it. And that is by increasing the efficiency of technology. So the promise of AI, we're putting all of our eggs in the AI basket, in my opinion. And so on the one hand, it could be we can't keep up with demand. On the other hand, it could be 3 years from now, there could be data centers that are built full of GPUs that aren't being used. I know that sounds crazy. Like, well, that's impossible. We're headed into a future where well, Dave, didn't you just say energy was going to be the problem? now you're saying we're going to have to decommission windmills because we don't need the power anymore. That's another one of those parallel universe possibilities in my mind.
All right, I think we're going to close this here. However, in defense of loan officers, of which one of them happens to be one of my best friends for life, they were screaming their heads off about this issue. They just got overruled by the so-called adults in the room. So.
Right. So yeah, the so-called, yes.
All right. One thing or another, what we can be certain of is hardware issues are cool again. Whether we have too much hardware remains to be seen. We'll be back in a minute. All right, folks, and we're back, and we're talking about another issue that's closely related to AI, and it's data gravity. Turns out that, well, all these models need a lot of data, and everybody's kind of trying to figure out how to manage that data. And truth be told, we were never all that good at it in the first place. But let's start with David here. We have a study here from Nutanix where they're talking about, well, everybody's tried to move data to something from one platform to another. But when I was much younger, people would tell me nothing good ever happens when you move data. Just it's costly. It's a security problem. Nothing ever fits in the format, and you wind up buying more hardware. So, do we need to go back to the old days where we just bring compute to the data?
Yes, and get off my lawn. Yeah, I think that look, the data gravity is something that's real because of just the sort of physics involved with moving data around. Also, there is the emotional gravity associated with, you know what? I kind of like the idea of the core of my business being under lock and key in a physical facility that I have control over, as opposed to being in the ethereal cloud. So it is an issue. I think it's going to, in the AI space, it's going to manifest itself the way that we've sort of, the four of us have alluded to here, which is this idea of some things happening on premises or in now what we call edge data centers, because they're not the mega cloud data centers. So I think that data gravity is going to make a lot of those decisions easier to say, hey, look, I don't want my data going over a national border. I don't want my data. I want my data being air gapped from general use. And so I think a lot of these smaller, lighter weight models are going to be deployed on premises, and they're going to reason over data that is in people's data centers. So this whole idea of when are we 100% cloud remains the same. It's like the vanishing point on a highway. You look up ahead and it's like, look at that in the distance, the two sides of the roads converge. The closer you get there, the further you are away from that point. So that's how I see data gravity manifesting itself.
Mitch, data engineers, are they the cool kids in the neighborhood now? Because we need these folks to figure out what to do with all this data, and I don't think the storage administrator is necessarily up to the task.
Oh, it's a lot more than just storing it, right? Not that isn't important in performance for applications, but how you organize data and different applications as well as technologies, AI versus conventional applications, how they use that data makes a big difference. So we end up with all kinds of things, caching and vector database and things like that to accelerate them. But if you were going to go into a computer science degree today, I would say go into data or data AI and engineering, because that problem is not going away and it's only going to increase. As far as location, I used to talk about data gravity. Now I talk about data, the stickiness of data. It's really sticky and hard to pick it up and move it. It's even worse when you step in it, because now you get all sticky trying to mess around with that data if you don't know what you're doing. And it's easy to, for someone who's maybe less experienced or doesn't have data engineering experience, it's easy to construct models, spreadsheets, algorithms, whatever it might be, and not actually be getting the correct answers because you don't understand the contextualization of the model. And one of the things that we have that's helping with that is graph databases, which connects data from a lot of different sources and gives the context of here's Mitch and here's who he is and here's the applications he's using, but what is he doing in those apps and how does that data relate to each other when you go across data sources? So I think that's an interesting area. We see it especially with AI as you try to do things like automate tasks. Well, I need more than just knowing this is the task. How does it fit into some workflow or process?
Correct me if I'm wrong, but I think one concern business leaders would have in this area is if they're spreading this data out among all these different sources, some of it, in the cloud, on premises, it's everywhere, that security is a big concern. Huge.
Yeah, spot on.
Yeah, if for no other reason than psychologically it's a concern, I think that the hyperscale cloud vendors would argue that their security, it's like, I feel more comfortable with my money under my mattress, but is it really safer there than in a bank? And the cloud providers would argue that actually, despite hearing horrible stories every once in a while, statistically you're much safer that way. But that doesn't matter. We still have humans in the loop, and a lot of people are more comfortable just saying no, we're not going to play that game.
Well, the FDIC will not insure your mattress, so that's the first issue.
But only up to $250,000, so be careful. You put it in your mattress anyway.
All right. David, you mentioned that you are living near where the original gold rush was in California.
Yeah.
AI has a certain feel of it to be the great gold rush of our times, and yet if we look back in time, the people who made the most money in the gold rush were selling dungarees and shovels, and so is storage and data going to be the shovels and dungarees of AI?
Are you asking storage?
Yep, storage systems and data management. Yeah, is that where the money is going to really be?
Yeah, I'm almost incapable of being objective on that subject. I spent 20 years deep in the storage industry. My kids are enjoying fine educations thanks to the data storage industry. So I think that the feel to Mitch's point, it isn't so much about the storage systems themselves Why? Because we've gotten to a point where it's sort of expected that these things aren't going to lose your data. So we take that for granted, and the real value add is in the data science layer. So I would say that the gold rush really is in the in loosely termed the kind of the data science layer, the idea of prompt engineering and people who can connect the dots between the bits and the bytes and the business value of data. That's where I think the gold rush is. That's what I tell my kids to go after. Be that person who can translate between the deep tech and the business value, and you're going to be fine forever.
Weird days. I'm like having a flashback to 10 years ago when I went to this conference, and I remember the developers would be hanging out in like some cafe, lucky if they got a beer and a pretzel, and all the storage guys were staying at the Ritz-Carlton on the other side of town.
Right. Same kind of thing. Yeah, it's not glamorous. High-tech plumbing is what we used to say it is, but plumbing is important.
There you go. Amanda, I would swear on Techstrong AI, every fourth article now is about data management issues, but maybe I'm just biased in that direction. But do you think that this has become a focal point conversation?
Oh, of course. As you mentioned, every other article seems to be centered around data and managing the data. And when I have interviews with different business leaders, half the time it comes back to data.
Right. Mitch, what is your best advice? You've been doing this for a while. And when confronted with a large amount of data and somebody says, we're going to move this somewhere, should I just say no in a kind of a Nancy Reagan kind of way? Or is there some other... is there some other way to like think about this in an intelligent fashion?
I'm going to give you an answer you aren't expecting. I kind of learned that by observing earlier in my career. You mentioned I've been around for a while. You always want to be the third project manager. You don't want to be the first or the second that's tried to move the data because expectations were inflated. First one fails wildly. Second one comes in, tries to pick up the pieces, just not enough to get it going. Third project manager comes in and saves the day. So don't be the first one to try to lift all your data to the cloud or back home or everywhere. So what I'm really trying to say is there's a lot of learning and experience you gain from trying to do this, and you can learn from others. Don't go it alone. This is not an easy topic to take on. Be the third project manager.
David, you've done storage and data. I've seen more than a few CIOs lose their jobs because of some massive data management initiative that got launched and just outright failed. So is this kind of a career-threatening decision?
Well, CIO stands for career is over. So I think that's sort of a given in some circles. Yeah, it's scary. And you talk about, being proud, it's like, we're number three. Be the third project manager. CIOs are hesitant to take on projects that might go beyond, where the positive ROI is beyond the average tenure of a CIO. There's a psychological hurdle to get over when if something realistically is going to take 24 months and there's no way the business is going to tolerate that kind of time horizon, what do you do? So you see a lot of companies with twine and twigs and gum and, putting patches on things instead of having a real, strategic plan, because that strategic plan is going to take too long.
Or hire the consultant so you can blame them when it goes wrong.
Exactly.
Right?
No, that plausible deniability. I mean, it's amazing. Hundreds of millions of dollars worth of plausible deniability to be able to point to a Bain and McKinsey or an Accenture and say, but they said that seems to be worth its weight in gold, to go back to the gold rush analogy.
It's real.
Well, maybe you should, at the end of your career, launch that 3-year project with 2 years to go to retirement. So, you kind of like just bail out before it comes to fruition or not comes to fruition.
Yeah. Good advice.
Good.
You have a future in career coaching.
There you go.
Yeah.
I would just point out one thing, right? As we joke, but David, the volume of data continues to increase, but it's more diverse than ever. It's getting harder to manage. And it's moving faster than ever. And some of this data is at rest, and some of it is in the cloud, and some of it's being analyzed in flight using various platforms like Kafka. Is this whole thing just taken on a new era? Have we entered a new phase of data management and analysis?
I think it's an extension of what we've been going through for a long time. But yeah, the problems, you look at the rate at which networking bandwidth and throughput has increased versus the scale of data increase, and we're not keeping up. It's not. It's like, yeah, we all think we're cool because we can stream 4K videos, but try moving a petabyte of data over the internet. Good luck. That's why there are physical devices that if you're doing a wholesale move into the cloud, they will send a semi truck full of essentially hard drives to load your data up and bring it over. And then there's the question of data synchronization, active, passive, business continuance strategies. It becomes very, very, very expensive. And the frustrating thing is 80% of that data is probably garbage, but you just can't, but the cost associated with pruning and tuning sometimes exceeds the cost of just saying, you know what? We're just going to have a storage facility and we're going to keep all the kids' toys there. And we're not going to get rid of anything because you never know. We might need that Barbie. And so therein lies the challenge. And I don't think it's going to be solved in my lifetime. I think that inefficiencies are going to exist in the system and they're just going to get worse.
So you're saying there's caravans of data traveling across the world we have to watch out for.
Yes.
Caravans.
Well, there's an auditor that's going to come looking for that piece of data in 5 years from now. I swear right. It's going to be that one.
You were the CIO that deleted it.
Yeah.
Yeah, exactly. And now you're going to jail. I know that sounds like a joke, but it's serious. No, these people, it can be serious consequences for not protecting data. But yeah, look, I'll tell you that my colleagues from the data storage industry, we sort of look at it from an AI perspective, and you look at all of the traditional ways of storing data, and many of them just don't apply. So there are new models necessary for storing data that's going to be accessed in the world of machine learning and AI that are different than some of the traditional ways that most data is still being stored. Yeah.
I think another thing to add to what you're saying, David, is we have so many more things that emit data now, and we have such an easily available storage because of the cloud, right? I don't have to go buy a rack full of a NAS or something to store it. But, we used to just let logs coming out of any piece of software just kind of roll off. We kept them in case we need them, after 2 weeks, they rolled off. Now we keep that stuff and we put it into the Splunks of the world and use it for analysis. Our IoT devices emit tons of data. We add telemetry information to applications to understand what parts are people using, what's performing well, all that kind of usage information. And that's just, 3 examples of 1,000 or 10,000 things. So part of the growth, the rapid growth of data is that we're emitting more and we're keeping all of that data, not necessarily always using it, but that's some of the promise, I think, of AI ML is using more of that. But to your point, the world has changed in that way. We have the things that got us here, and then we have all these new sources that have taken us to where we are.
I think it's pretty clear at this point, we're going to end this section here, that if you want to succeed in IT, as always, stay close to the data because that's where the money is. We'll be back in a minute.
Discover Techstrong Group, the epicenter of tech innovation. We're your go-to for reaching IT leaders and practitioners worldwide. Our secret? Impactful content that sparks awareness, engagement, and top-quality leads. With us, you'll access editorial websites, streaming videos, virtual events, custom content, analyst research, and more. Join our satisfied clients. Let's revolutionize your tech journey. Contact us today and tell your story to the world in the most powerful way with Techstrong Group.
All right, folks, and we're back for our third segment. And AWS kind of surprised a lot of folks. They announced that they would no longer be taking on new customers for a slew of services that they launched, including a cloud-based IDE and a Git repository that took everybody. It took everybody back a little bit on two counts. One is the announcement itself seemed a little abrupt. It was just kind of put out there, and a lot of the customers were surprised. And secondarily, AWS has kind of been positioning itself as the back end for DevOps for a lot of developers. And these services that they're turning off were at least considered by some of us strategic, but maybe not. But Mitch, what's your take on what's going on here with this whole thing? And is AWS kind of shifting a gear in your opinion?
Well, I think it's several factors. One, if you were kind of entering the cloud era, maybe you didn't have the tools to develop for the cloud. That's when a lot of these services, even though there's more recent ones, kind of made sense to use. Now we live in a multi-cloud world, right? So do you want to be stuck with your development environment in one hyperscaler that maybe is even more attuned to that? Or you already have these things. You already use GitHub, or you have whatever you're using for source code management. You have DevOps platforms and automation tools, CI/CD platforms. So, for AWS to compete in all those different parts of the development tool, DevOps tool, security tool markets, I think it's just a recognition to say, people need more than what an AWS would provide, and AWS would be better to partner with those companies and make that extremely easy. So if you're already using a Circle CI for your CI/CD, or you're in Jenkins and CloudBees or whatever, great, come in. We have a great environment for you to work in, and we'll work with your GitHub or whatever you're using for your code management, et cetera. So I think it's just a recognition that people don't want to get it, aren't looking to get their IDE from a cloud.
David, do you think that from a IT leader perspective, this is a cautionary tale about not jumping in too early with something and wait and see if it actually is going to be around?
What it means is you should always be aware that change is going to come around every corner, and you need to be prepared for it. So to the extent that you can hedge, to the extent that you can avoid vendor lock-in, yeah, that's great. From an AWS perspective, I see this as the sign of a healthy, well-managed business, frankly. You don't hear about things like this from companies that are fat and happy and bloated and ignoring the ruthless optimization of their business to stay ahead of the disruption curve. It's hard for some of us, for all of us, really to get our emotional heads around the idea that AWS could go out of business eventually because they'll be disrupted by something else. Seems impossible to conceive of, but I guarantee you there are people at AWS, just like there have been people at Microsoft and other companies, who wake up in the morning thinking, the end is near. What do we need to do to make sure that we don't fall prey to what happened to all of these other companies before us? So I see this as a healthy thing. They're identifying things that are like, look, there's going to be some pain associated with it, but ultimately it's healthy pruning in order to better serve customers. So I don't think there's anything negative here. I'm sure there are going to be, you could anecdotally find people who are really upset by this because their whole workflow is based on some tool set. But they're not going to cut off at the knees. This is like any end of life cycle product sort of thing. They're going to maintain it. There will be people 3 years from now using every single one of these tools.
Mitch, how far down multi-cloud are we? Because when I talk to folks, they'll say we're multi-cloud, but they're 90% in one cloud, and then they're on-premise, and then they've got a smattering of other stuff. Are we moving to a model now where developers are building applications where they're invoking resources that exist in different clouds? And if I'm running IT, I need to kind of think about it in those contexts these days, because all those things are just an API call away if I think about it.
Well, for a lot of folks, multi-cloud is kind of like the relatives you gain when you get married, right? So you do an M&A transaction, which many companies go through. You're probably not going to, let's don't buy those people because they're in Azure and we're in AWS or something else. You acquire, and then you have to make the decision to centralize and move things is a tough one. It usually doesn't happen unless you've got a really good process for just acquiring companies and moving their stuff in. That for somebody that's doing like a roll-up or something like that. So a lot of multi-cloud is just, yes, we do 90% of our stuff in Azure, and we bought these other 3 companies, and they're in 3 other clouds too. So guess what? We're multi-cloud. We have to figure out how to work with that. So I think that's a big part of it. The other, we were talking about the development tools from AWS. A lot of things have changed in the cloud providers. You look at a Cloudflare and all the development capabilities that they've added to their offerings, whether it's security tools or workers at the edge of the network. You look at Akamai, who acquired Linode, which is a very friendly, developer-friendly environment to add to their CDN, now kind of larger cloud. So developers working with your cloud through APIs and tools and things like that is much more commonplace and easier to do versus kind of being centralized in one cloud. That's just sort of a fact of life for all of us.
David, have you seen any effort to kind of go multi-cloud in a more proactive manner versus what Mitch just described, I would say is more reactionary because, I inherited it somehow?
Yeah. I think that a lot of folks have been down the path of thinking that multi-cloud was going to be substantively different than a multi-vendor strategy. But setting aside for a moment the idea of acquisitions, and we were Azure people, and we just, I just married into an AWS family. What are we going to do? Thanksgiving, Uncle S3 comes over and gets drunk. It's going to be embarrassing. I think the idea of cloud bursting and on Tuesdays we'll run this in AWS, but on Thursdays and Fridays we're going to run this in GCP because we're going to save 10%. I think a lot of that isn't even on the table anymore. I think a lot of it is fit for function, the perception that some providers fit certain categories better than others. And largely it's hey, AWS, I'm thinking about doing this. How much are you going to charge me? And when you have enough power, I'm talking about large IT shops, because Azure's telling me that they'll do it for half the price. And so you get that sort of, you're not locked in and you have that as a hedge. So I'd say the best multi-cloud strategy is, frankly, 60, 70, 80% of your stuff's running of your stuff that's going to be in a hyperscale cloud. 60, 70, 80% of it is with one cloud. And then you have your second provider that's doing maybe 20, 25%, 30%. And then you have a third provider who's out there in the wings waiting to get a taste of your business at some point. That's how you keep things honest. So I think if most of multi-cloud is a multi-vendor management strategy. But that's my perspective.
Back in the day, if I just wanted to threaten a vendor, I would just get a coffee cup from their competitor and have it on my desk anytime the sales rep came.
Same thing.
You just have a login screen to the competitor on your monitor when they come to visit you.
It's amazing. It's the $1 million GCP mug. All you have to do is take a sip out of it, and all of a sudden you save $1 million.
Really good coffee. Tastes really good out of this cup.
Really good cup.
So back in recently, actually, I was talking to this person and I said, what is ultimately the difference between your IT team and the IT teams you see at Google and Microsoft and Amazon and these other places? And without batting an eyelash, he basically looked at me and he said, well, they have engineers and I have administrators. And his point was that the talent that is building those services out at those platforms, it tends to be much more sophisticated, shall we say, than the average IT administrator who, And it was basically running things historically through a GUI on, say, VMware vSphere, right? It takes some level of skill, but it's not quite the same. His point, though, and one of the things that he illustrated was they use software engineering to go build actual control planes for those platforms, and that's what allows them to manage these clouds at scale. And the average enterprise still hasn't quite mastered a single control plane, never mind a multi-cloud control plane. So, David, let me start with you. Do we need to, maybe if we wanted to get to this hybrid cloud thought process, rethink the way the control planes are structured, and IT organizations are going to have to go build one or find one somehow that works against multiple clouds?
I don't know. I may be showing my age here, but whenever what I hear when in this discussion is, wouldn't a single pane of glass be nice? That's what we would call it.
It is a variation of that thing.
Yeah, single pane of glass, universal remote control. And I think, yeah, every universal remote control, because yeah, okay, great. Change the channel, adjust the volume. Fantastic. But what about the deeper functionality in the devices? You know, it just starts to fall short. And then the single pane of glass, well, what person in the organization needs to see everything and needs to have the level of granular control that a single pane of glass would deliver? And what is the complexity that's involved? Now, yes, if you're a GCP, you're an Azure, you're an AWS, coming up with a control plane to control all of your stuff that you control, that's different than being an IT organization that's bringing in third-party tools that have to somehow be integrated together. And so if I'm advising a company, I tell them to not try to find some magical universal control plane, but instead double down on your relationship. Pick a horse and ride it. Double down on the relationship. There is no absolute right answer for the set of tools you're going to use. And the difference between an administrator and an engineer, frankly, becomes kind of gray when you get into the driving of the race car versus the building of the race car. So yes, those clouds have got engineers, but what are they engineering? They're not engineering something that's the same as IT infrastructure for an individual company. So I'm not that impressed by the idea that you can take what AWS does internally for their own operations and model that within Ford Motor Company, or whatever company.
What do you think, Mitch? We hear about platform engineering and DevOps all the time. Are we moving down this path? And maybe it may take a while, but it seems like folks are attempting it.
I recall a point in time where I thought it was early in the OpenShift days, and I had one of my administrators, and I thought it was a really good idea to try to set this up in our environment to have kind of our own internal compute platform and storage platform that we could share across all of our projects. And that turned into a gigantic failure. Not anything against OpenShift. It was just so complex. It was beyond what we could do. So I'll get to your question in a second, but there's another name for a single pane of glass, which is single glass of pain, which is trying to really leverage that and do it correctly. There's no one silver bullet to this. I think that the fundamental thing that part of this conversation is that what you're doing, the business you're in, and the business AWS and GCP and Azure and everybody else are in, are two drastically different businesses. I'm running a hospital supply business. I'm running an insurance company business, or I'm doing, the technology for that. I have no business trying to take OpenShift and creating my own internal platform for hosting applications when I'm going to go to somebody who spends all of their dollars on doing that as their business. And they will spend infinitely more money than I ever could. And I may do some things to help us. Large enterprises do invest in some of those things, but even them, it doesn't make sense. So platform engineering, to get to your question, is to me is more about taking the erector set of options and saying, here's what we're going to use. Let's use these 5 configurations. And if you use those, we'll support them and we'll update them and we'll make those updates easier. And you can concentrate on the fun stuff that you like to do in testing or software development or whatever it might be. And that's one of the ways. And by doing that, we'll take advantage of some things that cloud providers do really well that we don't have to do for ourselves anymore. Or handle some of the challenges around upgrading and interdependencies that you might have, or work on performance, security, things like that. So I think platform engineering is trying to take, everybody has to build the fundamental pieces out of the erector set to eventually build what they're going to create. And it's about getting those starting pieces in place for you so you can be more productive.
Yeah. David, what do we do about this fundamental problem of IT management? Because today, every time I add a platform, I add more people. The biggest cost center of IT remains the people. So, is AI going to solve all this problem for us? And maybe we can get to the land of hybrid cloud nirvana through AI, or are we just stuck here forever?
AI solves all problems. All problems. There are no, if I had a whiteboard, I would draw the formula out that shows that there are no problems in the presence of AI. So let's be clear about that. No, AI doesn't solve it. The greatest line that Mitch just delivered that I'm going to remember for the rest of my life is, here's what we're going to use. Getting to that here's what we're going to use is such an overly complicated, resource-intensive process. And I firmly believe that if people spent 20% of the time figuring out, here's what we're going to use, and just said, here's what we're going to use, throw a dart at a dartboard, make the decision, and roll with it, and then make sure you have the expertise in the team to address the inevitable mismatches and things, and build your system together and ride that horse and have really strong partnerships with your vendors that you're buying from. That's the way to go. So no, I don't think AI is, there are AI-based tools that will help people be more efficient as we augment human intelligence, inevitably. But the problem is going to go into the future. It's going to be worse because things get more complicated. But the number one thing is just make a decision, for the love of Pete. Make a decision and get on with it.
AI is not EMC squared, right? It is not the answer for all things.
Well, I worked for EMC, and the squared was for C Corporation, but
yeah, that's true.
But
different kind of
EMC.
All right, folks, we're going to see how all of this plays out. But I think the most important thing to remember is, if you do make a decision about who you're going to the dance with, just be aware of the fact that you're going to dance with them all night long, because there are no new partners after that. So, gentlemen, Amanda, thank you for being on the show.
Great to see everybody.
You bet.
All right.
A lot of fun.
And thank you all for watching the latest episode of the Techstrong Gang. We have an awesome lineup of content coming up right after this on Techstrong TV. Stay tuned.
I'm Bonnie Schneider, sustainability contributor to the Techstrong Group. I'm excited to introduce you to a groundbreaking new initiative from Techstrong Research, the Sustainability Pulse Meter. The Pulse Meter offers valuable insights into how environmental responsibility factors into tech purchasing decisions for key players in the industry. Position your company as a leader in the industry and differentiate from your competitors with the Sustainability Pulse Meter, offered exclusively from Techstrong Research.